where do you put your temperature sensor for your whole system? Do you put it in the boiler supply side or the system supply side, or do you put it on the system return side? Where do you locate it? And I'm just trying to get you to fully understand we've got to look at return water temperature. It's critical if you're going to make a condensing application running that boiler. We've got to have cold water coming back. So humor me for just a second. A real simple question here. Let's put it on the supply side. Let's put it on the system supply side and see what happens at less than full load with the delta T and return temperatures, and ask the question, will the boiler condense? That's kind of the question we got to have. So here we go. If we locate the sensor in the system supply side, and let's say we set it for 140, and let's say we set it system supply side at 140, and we got a 20-degree delta T at full load, and let's don't worry about whether it's flowing variable or constant flow. Let's just keep a constant flow, take a snapshot. Here's my question to you. At 100% load, 20-degree delta T, full flow, we got condensing going on. We got 120-degree return water, supply is 140. Question is, what would happen at half load if we reduce the load to 50% and did not change the flow rate? We're going to keep the flow rate constant. I want you to understand the impact on the return temperature. So if we're holding a constant supply of 140 and we go to half load and we don't change the flow rate, what happens to the return? Obviously, the return temperature goes to half that of 20 to 10, so the return temperature is now 130. So the design was 140 to 120, you were condensing. At half load, same flow rate, you got a return at 130 and you're no longer condensing. So the point of it is, what happens to your return water temperature if you keep the flow rate up? Now hopefully we're varying the flow rate, but in case we were not, that's what would happen. What would happen if we went to the return side? What would happen if we just said, okay, we're going to control this on system return. We're going to hold that system return at 120 because we know at 120 it's always condensing with natural gas is what we're after. Ask the same question. 100% full load, you'd have a supply of 140, you'd have a return of 120, and you're controlling to the 120. What would happen at 50% load in BTUs if I didn't change the flow rate? I'm going to hold the GPM constant. I'm going to hold the 120 return constant. So now the variable is going to be the supply temperature. What happens to the supply? Obviously 120 to 140 full load, 120 to 130 at 50% load, but we are still condensing because we're controlling the return water temperature at 120. Now we very seldom do this simply because of the response time, so don't walk away thinking that's the answer. I just want you to understand the impact of where you put your controls and what happens. So the return water side would keep you condensing, but most people don't go there because of response time. Because once you fire the boiler, how long does it take that gallon of water to get through your whole system and back to the sensor? It might take several minutes, and you could be in trouble doing that. So in reality is traditionally, and where we normally see the boiler supply water temperature sensor located is in the system. Traditional location would be system supply. But remember, we want to look at that load a little bit. We want to make sure we got multiple boilers running at cold water as possible at low fire. That's how you maximize the efficiencies of these systems.